Hi, it's 5.4. It's what 5.4, 5.5 is what we're going to be doing, which is the difference and the sum of cubes. And I call it the cube, is what I call it. And they had us multiplying things together, and that's what we've been kind of doing, is multiplying it together and seeing, how to go backwards kind of on it, because that's what factoring is going backwards from your multiplying. And so I guess a couple of things I want to verify with you guys on this is when I multiply this together, look at what you have. And this is what they asked me to do in chapter 4, is multiply them together. So x times x to the second. So this is a good review of chapter 4. X to the third. It's a count, right, of the x's. This is 1x. X squared means x. So all together, when they're all together, there's my fingers all together, there's 3 of them, which when you count them, 1, 2, 3 is x to the third, right? So you get your fingers out. And then here, a positive times a negative is a negative. This is a 1. 1 times 2 is 2. And then x, right? X. Now, it's okay to use the product rule, but you can also use the definition. And x means count them. There's 2, x to the second. If you use the quotient, if you use the product rule, when you add the exponents, when you have x, and you add the exponents are 1, and 1 plus 1 is 2, right? Okay, so here we're going to get plus 4x. And then we're all done with the x. We did it to all 3 of them. We distributed it. And so we learned from chapter 4 that there was going to be 6 multiplies here. So I'm going to have to do the remaining 3. And quite often there are like terms lining up, right? And so here we're going to have plus 2x squared to see how that's lined up. So that's why I lined it up, the x squareds together. And here is minus 4x and positive 8. And then when I combine like terms, the middles drop away, and I get x cubed plus 8 is what I get. And this is a special guy. It's called a cube because it's made up of x times x times x. And this is special as well because 8, I don't know if you guys are remembering, but 8 was 2 times 2 times 2. And so that is also called a cube because there's 1, 2, 3. It can be written in that special way. Now 9 can't be written in that special way. There aren't 3 numbers that are the same. This times this times this, where these are all the same and nice integers. So there is a number, but not a nice integer. That when I multiply them together, I get 9, the same, right? It has to be a nice integer, though. And these have to be the same. So that's what makes 8 kind of special. It's a cube. 8's a cube because it can be written that way. Okay, I want to show you this guy over here too. So when I multiply those together, I get 27. 3 times 9 is 27, and it's x to the third. And then here I get plus 36, x to the second. And then here I get 3 times 16, I think it's 48, so plus 48x. Minus 36, x to the second. Minus 48, 4 times 12 is 48, x. Verify with your calculator. So I'm okay. Gosh, where did all the calculators go? There is no... I'm going to have to call the police and report a robbery of my calculators. I found them. So here's this one here, and 4 times 12, right, is 48. And so, and then we have 4 times 16, which is, I think, 64, so minus 64. And you can verify, right, 4 times 16. I didn't put in the negative, but you could have put in the negative. You could have said, well, it's negative 4. Okay, it's negative 4, so it's negative 64. And when the dust clears here, the middle terms drop out, and we get 27x to the third minus 64. And does that always happen? When you multiply a binomial times a trinomial, does it always turn out to be a binomial? And if you're remembering back in chapter 4, so since I'm going to put it up here, I can't help it, but if you're remembering back in chapter 4, they asked you to multiply this together. I don't know. I'm going to have a minus in there as well. I'll put a minus right here, and I'll call it minus 10. I don't know. Anyway, when I multiply this together, it's not going to turn out to be a binomial. When I multiply this together, I'm going to get x to the third. So I'm going to do it because practice, right? Chapter 4, plus 3x to the second, right? Minus 10x, minus 2x to the second, minus 6x, plus 20. So I get x to the third plus x squared, 1x squared, minus 16x, and plus 20. So it turned out to be something that has 4 terms, not something that is a binomial. And so this is really, really special when this happens. And so it doesn't happen just with just random numbers, okay? And so the thing to notice is that when this special thing does happen, it's that this is a perfect cube and that this is a perfect cube. Notice 8's in my perfect cube list because 8 is 2 times 2 times 2. We were talking about that. And the other perfect cube is x to the third because that's x times x times x, right? And see 27's in my list. It's 3 to the third. And 64's in my list, 4 to the third. And x to the third again is in my list. And so those are perfect cubes. Now I want you to notice that the list between perfect squares and perfect cubes has some friends, right? So perfect squares, there are some numbers that might trick you. So just seeing that I have that number doesn't tell me what it is, a cube or a perfect square, because like 1 is in both lists, because 1 equaled 1 to the second as well. So 1 is both a perfect square and a perfect cube. It's a tricky guy. And so is 64. 64 is also 8 to the second. 8 squared. It's 4 to the third, but it's also 8 to the second. So you kind of have to watch out because there's some things that are both perfect squares and perfect cubes. So sometimes people will tell me, well, I knew it was a perfect square because it had 64 and not that it was a cube. Well, when it's 64, you don't know if it's a square or a cube. You have to use other clues. And so, whereas if you have 343, well, for sure, it's not one of these. So that kind of tells you, hey, it's a cube. And another one, so x to the third is a really clear sign that it's a cube. But x to the sixth, I don't know if you guys remember, but x to the sixth is a perfect square. It's x to the third raised to the second. And so it's in both lists, x to the sixth. So there's some that are tricky and some that are very clear what they are. Okay, so now we're going to look at the factoring strategy. And don't worry, we're going to keep practicing. And then the next video, this is 5.5, even though I tried to call it 5.4 earlier, but 5.5. And the next video is just more practicing factoring. So we're going to be practicing our factoring a lot and a lot more. I mean, we're just practice factor. Factoring is the F word of beginning algebra. And so fractions are the F word of arithmetic. But factoring is what, and functions are the F word of intermediate algebra. And we're going to do functions this semester as well. So the first step in factoring is to factor out the greatest common factor. That's every time. Then you count the terms and you ask yourself, is it a difference of squares? And if it's a difference of squares, then this is how you factored it. And we've been practicing the difference of squares. We did that in 5.4. We're going to practice some more today in this lesson. Okay, if it's not a difference of squares, then you ask yourself, is it a cube? And unfortunately, this went onto the other page with mine. So you want to make sure that it's a cube by identifying the bases. And then I factor it by monomial, just the same as I did the difference of squares by monomial. Now it's a more complicated monomial, because monomial, not mon. So more, I factor it by words, which, what is that called? When you have a words that go with, I can't think of it right now. But this is my song that I sing. So I sing finger over threes, write what you see, square, multiply, square, soap. And I know it's square the first base and multiply the bases and square the last base, but that's not what I sing. I sing finger over threes, write what you see, square, multiply, square. Now, this formula right here that I have at the top of this page is also my song. It's finger over threes, write what you see. So you'll be, if you put your finger over your threes, right, your exponent threes, and you write what you see, you're going to have A minus B. So that's how my song works. And then it's square this, A squared. Then it's multiply these two things together, AB. Then it's square that, boink, and then it's soap, S-O-A-P. And what those signs stand for is same as you started with, which was minus, opposite of this, always positive. So that's what the AP stands for, always positive. And this is opposite. Opposite of this, which is the same as that. Ah, I missed. Same as that. And this same song, if you will, or formula, so if you are a formula memorizer, then you have to memorize both formulas and figure out how you're going to use them. But if you're a song singer, then both cube formulas go with the same song. Finger over threes, write what you see, and so I'll be writing B plus A plus B, A plus B. Sorry, I don't know why my fingers were so wide is why, and I got reading it backwards, right? A plus B, in it goes. Then you take this and you square it, boink. Then you take these two things and you multiply them together, boink. Then you take that and you square it, B squared. And the signs go soap. The song kind of ends abruptly, soap. So same as you started with, plus, opposite of that, and then now the always positive's making sense, right? Because always positive in both formulas, it's positive, whereas the signs are different for the other formula. And then if it's a sum of squares, it's prime. And so this becomes our thought, breaking it down into just a quick nutshell when you have a binomial. Greatest common factor, and then if it's a binomial, because we worry about the size, binomial, difference of squares, a cube, and then to me, anything that's not this or this is prime, whether it's a sum of squares or not. Now the sum of squares, the reason they keep bringing it up, that it's prime, when there's lots of things that are prime, is because it tricks people because it's so close to the difference of squares. It has just the difference. So this is how a binomial will factor. Greatest common factor, if it's a binomial, difference of squares cubed. There's only three things it could be, and the order that you want to check it in. So some people know that it's a binomial from the beginning. Now I can't help but notice it's a binomial. Then these are the three things I want to check. Is it one of those? And it might be more than one of them. Okay, so I notice that this thing is a binomial. I can't help it. So every time binomial, greatest common factor, second step, difference of squares, third step, cube. That's the only thing that it could be. So, and it could be more than one of those things. So I'm asking myself, does this have a greatest common factor? Well, the number here is 1. so they only have 1 in common for the numbers. They don't both have an a, so the greatest common factor is 1. So that means do nothing. Everything has 1 in common. So to say that there's not a greatest common factor is kind of silly, but it's a do nothing if you have 1. Well, is it a difference of squares? Well, in order to be a perfect square, this has to be a raised to an even, and it's a to the third. So I can already say nope, and it doesn't matter if this is a minus and if that had been a perfect square or not. It doesn't matter. Then I ask myself, is it a cube? Now on a cube, it could be a sum or it can be a difference. So it's not a difference of squares. A cube can be a plus or a minus. So is this a perfect cube? Yes. So what you have to check is if it's a perfect cube, PC, perfect cube, right? And then it could be plus or minus, and then PC. So that's what it's going to look like. A perfect cube, plus or minus, and then a perfect cube. So we don't have to worry about the sign in between. Is 8 a perfect cube? Yeah, it is. So then I want to write to myself, what cubed minus what cubed? So I'm like, yes, this is what this is, right? And I want to fill those in. Of course, the A is easy. And it's really, I'm really doing this so that we'll know what's here. What do you guys think it is? So you can go back here and you can look right here. Boink. It's 2, right? And these are things that they say that you should memorize. If you don't want to memorize it, I can show you how to do it, and you don't know it, I can show you how to do it on your calculator. It's not the square root, it's the cube root. See it, the 3? So I want to hit shift and the cube root, and then I want to take the cube root of 8, because I'm thinking that's a perfect cube, right? And then when I do that, it says, yep, it is, it's 2. 2 to the third is equal to 8. So your calculator will do it, which is really nice that it will. And then I whip out my song. So I go like this when I'm factoring it. I know that it's going to be a binomial times a trinomial. So I make my binomial, and then I make my trinomial here. And then I go like this. Finger over 3's, write what you see. So I'm going to be writing inside this binomial a minus 2. Then my song goes on, square. So right here, for this spot right here, my song is square. And what do I square? I square the first thing, which is A, and put it, the answer right there. So A squared, right? So I'm going to erase my little dot. And of course, I usually just sing the song. I don't usually write out all the mnemonic device. That's what it was looking like. And it was getting monomial. It was going mnemonic, and it was almost going there. And then the next thing is in the center here. And what you do is you multiply the two bases. And the bases are the part that are below the exponent. So that's A multiplied by 2, which is 2A. And then the last here is square. So that's what I sing to myself. So here I sing finger over 3's. Write what you see. I don't write it though, I sing it. Finger over 3's, write what you see. So I'm here having my finger over the 3, so I crossed them out because I can't put my finger over them and you see them at the same time. And then I'm writing what I see, which is A minus 2. I leave out the parentheses around it, right? And then I'm squaring, and what do I square? I square the last thing and put it in the last spot. So I'm going to square 2. 2 squared, and 2 squared is 4. And then the song abruptly ends, soap. And this is talking about the signs that you have in between when you abruptly end soap. Okay. This says same as you started with, which I already have that in. This is opposite. So this was minus, so this is plus. AP is always positive. And then there's your answer, and you're all done. You don't have to do anything more. And so here's my answer. Now I want to talk about why it's all done and won't factor anymore. So here's my answer. And I want to talk about why it's all done and why it won't factor anymore. In order for it to factor more, that this piece right here would have to factor some more. And that is a binomial, but it doesn't have a greatest common factor, and it's not a difference of squares, and it's not a cube, right? This would have to be a to the second or a to the third to be a difference of squares, and a to the third to be a cube. So when it's just a, it's done. This is, so boink, 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 right? We're done. Okay, on a trinomial, which is this guy, is a trinomial, well, you have greatest common factor, which the greatest common factor here is 1. So you have to check it out. And the second thing you do is you unfoil, right? That's what you do on a trinomial to see if it will work. There's only one thing that will work on a trinomial. So I'm looking at that trinomial to see if it will factor a squared plus 2a plus 4. Will it work? Well, I can certainly do a times a. And when I do 4, that's 1 times 4 and 2 times 2. And it says add 'em, and it will always be add because the formula, remember, always positive. So will always be add. And when I add these, I get 5. 1 plus 4 is 5, which is not 2. When I add these, 2 plus 2 is not 2, right? 2 plus 2 is 4. And so it's that the middle will always be too little. So this trinomial built by the formula square multiply square will never factor, ever, for any numbers. There's no special numbers that will make it factor. And so this trinomial, you can always say is prime, and you don't have to try to factor it. Now, you don't say that it's prime. You don't write down prime, right? Because what you do, I did factor it, right? It started off this. I factored it to this. And now I'm saying, will this factor? No. Will this factor? No. And so I don't say it's prime because I factored something. You only write prime if you didn't get to factor anything. And I did get to factor something. I got to factor the cube, right? So we did a lovely job on that. And this is number 16 out of your book. And so I wouldn't be able to help myself. I can see it's a binomial, right? And you always can see, I mean, I always say, look at the size second, but people always can see it's a binomial, right? And so greatest common factor, this is how you factor a binomial. Greatest common factor, difference of squares, or a cube. If you say no, 1, no, then it's prime. It won't factor, okay? And so that's the deal with a binomial, and that's all we know how to factor on it. I'm looking at this, and I can't help but notice it's out of order. And if you want to leave your binomial in the order, you could factor it that way. But me, I would be like, let me reorder it, because it was out of order. And now greatest common factor. Well, 3 goes into 81. Do you guys agree? 3 goes into 81, right? You can get your calculator out to verify that it does. Goes in 27 times. So the greatest common factor is 3. And I want to pull the 3 to the front. And I'm going to write here y to the third, because 3 times y to the third is 3y to the third. 3 times what is 81? Yeah, remember we figured it out. It was 27, right? 27. So you're done with a monomial, but a binomial could factor further. So the 3 I'm done with. So here's my answer line. And now I'm on, will this factor further? I got my finger over the 3, right? And so is this a difference of squares? Well, it's not, because in order to be a difference of squares, this have to be y to the second, or y to the fourth, or y to the sixth. and it's not. It's y to the third. So being that it's y to the third, it makes me think that maybe instead it's a cube. So this is a cube, yes. This can be a plus or a minus when you have a cube. It doesn't matter. So it's a plus. And is this a perfect cube? And if you don't know, you can use your calculator, right? So you would get the right here and do the shift. And 27. Oops, I got a 5 in there instead of the 2. 27. So the cube root of 27 is 3. So it actually is, right? So I'm thinking that, hey, what cubed plus what cubed? Because that makes me feel like, yeah, this is a cube, right? Yes, it's a cube. So this was nope, wasn't that, right? And I did that already, and I got it out. I got my finger over it. So this is y. What goes in here? You got it, a 3. And then I whip out my song, and I go, when I say finger over 3's, it's because finger over the exponents didn't rhyme, but finger over 3's, write what you see, rhymed, where finger over the exponents, write what you see, didn't rhyme. And so I've got my finger over these exponents, and I'm writing, remember the formula, this is a binomial times a trinomial. And I'm putting in here y plus 3 for the binomial. And then you take this right here and you square it. And you put it right there, the result. So that's y squared right there. And then you take these two things and you multiply them together. So that's 3y. And you put it in the middle. Then you take this and you square it. 3 squared, right? 3 squared is 9. And you put it right there. And then you abruptly end the song with soap. Same as I started with. Opposite. So this was positive, so this will be negative if it's opposite. Always positive, plus. And then if you FOIL this together, more than FOIL, right? Multiply 6 times together, you'll get y to the third plus 27. So we've kind of got the special balance between what, the pluses and the minuses to make it cancel out like it did right here. We got that going, and the formula gets that going for you. And so how you can always check your answer. Okay, so the things that you have to check is that this will not factor further. Monomials are done. This is a binomial. Will it not factor further? Well, it'll only factor further if it's a greatest common factor, which it's 1, or if it's a difference of squares or a cube. But this is only y to the first. It takes y to the second or y to the third to even possibly be one of those things. It takes more special stuff than that, but it's not even possible because it's just y. And then this trinomial is always prime. This trinomial will never, ever factor. If you've used the cube formula to get it, it won't factor. The middle will always be too little. So you can see 1 and 9, 3 and 3. 1 and 9 add to 10. It's an add, right? 3 and 3 add to 6. So it'll never factor. So we know we're all done. So this is our answer. Now the other thing that you do to check an answer, besides making sure all the pieces don't factor further, so the other check is to multiply it back together and verify it's what you started with. And I didn't do that on the first one, and I want to do that on this one. And you want to go backwards of where you started. You want to multiply this together first, right? Because that's what I just factored. And then verify it's y to the third plus 27, right? So when I do y times y to the second is y to the third, y times here minus 3y squared, y times here plus 9y, here plus 3y to the second. I'm not surprised because I tried to make it like that by using the formula. The formula did it. So here is minus 9y. I'm not surprised. And here is plus 27, 3 times 9. And so when the dust clears on the inside here, I'm going to have 3 times whatever I have in here, which is y to the third plus 27, which is 3y to the third plus 81, right? 3 times 27 is 81. And that is what I started with. Oh, they had it out of order, so let me put it out of order, right? So check, right? So you check that each piece is done, then you multiply it together to make sure it's what you started with. So we did a lovely job on that. We checked it in everything. And so that's kind of the story on those. Would I have been able to factor this on my own? So could I factor this to this on my own if someone hadn't given me a formula? It's formula factoring. And whether you memorize the formula by writing it out like this, a cubed plus b cubed equals a plus b times a squared minus ab plus b squared, whether you memorize the formula like that, and then you start saying what your different pieces are. This is playing the part of y, this is playing the part of 3. Now go through, and everywhere you say a, put y, and everywhere you see b, put 3. Whether you do that or you sing the song that I sing, it doesn't matter. It's the same. You'll get the same. So notice how ours was y cubed plus 3 to the third, right? So everywhere we see a, we're going to be putting y. And everywhere we see b, this is a plus here. Did I get the sign in there? We're going to be putting, everywhere we see b, we're going to be putting in 3. So b is here times 3, and 3 to the third, right? And then 3 to the second, rather. I don't know why I said 3 to the third, but 3 to the second. And you want to clean things up. Why 3 like that? That's not how you write a variable and a number. You write the number first and the variable second. So this is, on my cleanup, y plus 3. If I'm a formula user, y squared minus 3y. 3 squared is 9. You should write 9. You should not write 3 squared. And so you notice that we get the same answer as we got, whether we use the formula or we use the song. It doesn't matter. And it's the same. So you be you. You do whatever you think would be helpful. A lot of times, it's when it finally clicks, right? This takes a few times of getting used to it. And so if it finally clicked when you use the formula, you'll like the formula. If it finally clicked when you use the song, you'll like the song. Either one of them, you have to memorize either one of them. They're not something that you would come up with on the fly. Okay. So I notice it's a binomial, 2 terms, 1, 2, buckle my shoe, right? So I can't help but think, well, how do I factor a binomial? And binomials are greatest common factor. So I'm asking myself, is there a greatest common factor other than 1? So what do you think? So you rest on the smallest number, which is 10, and ask yourself, does it go evenly into the other number? So I'm asking myself, is 640 divisible evenly by 10? And the answer is, yes, it is. So the greatest common factor is 10. And they don't have an A in common because they don't both have A's. And they don't have a B in common because they don't both have B's. So you pull out the 10. So 10 times 64, I still have it on my calculator, and then a to the third plus b to the third. And then monomials, which the 10 is, the greatest common factor is done. So I put that on my answer line. I don't want to forget you. So 10. Then I ask myself, I have a binomial still, right? My finger over that, there's a binomial. And now the greatest common factor in that binomial should be 1. They should only have 1 in common, and that has a number 1 right there, right? And so I ask myself, is it a difference of squares? And this one has they're trying to trick you, right? And the reason they're trying to trick you is because 64 is a perfect square. So you might be seeing the 64 and saying, yeah, it's a difference of squares, right? But wait a minute, it has to be a perfect square. So that would have to be a to the second, or a to the fourth, or a to the sixth. It has to be a multiple of 2. So to be a difference of squares, it would have been a to the second, or a to the fourth, or a to the sixth, or a to the eighth, etc. Right? That would be the possibilities. And so since it's a to the third, it's no to the difference of squares. The answer is no, it's not a difference of squares. So I asked myself, is it a cube? So even though 64 was seeming like a difference of squares, so I asked myself, it's a cube. And now I want to know, well, what about 64? Is that a cube? Well, yeah, it is. It's 4 to the third, right? You can go look on your paper, right? Or use your calculator. There it is, 4 to the third. And the exponent has to be 3. A to the third. Yeah, this is a cube. Yes. If you're saying, doesn't it have to be a minus? And on a cube, it's okie dokie to be a plus or a minus. So, you factor it however it makes you happy and compare with what I get when I factor it the way it makes me happy. So it makes me happy to get to sing a little song. So 4 to the third is 64, a to the third, and this is B. And so my little song is finger over threes, write what you see. And then it's square. Now you have to be careful on the square, because when you square this, a lot of times people make a mistake. This is 4a squared is what it is, to put that there. So that's 4a times 4a, which is 16a to the second. So sometimes people tell me that this is just 4a to the second. And then all they squared was the a, right? And or they'll tell me that it's 16a, and then they only squared the 4. So you have to square both. You have to square the 4 and the a. It's 16a to the second. Then it's multiply these together, which is 4ab, alphabetical order. And then you square this, so this is b to the second. And then SOAP, same as you started with, opposite, which is minus, always positive. And then this binomial does not have a greatest common factor other than 1. It's not a difference of squares, and it's not a cube, right? And this is the trinomial you get when you do the cube formula, and it's always prime. It doesn't never factor. It looks like it might factor, but it doesn't. The middle will always be too little, so it'll never work. So that's good news. Knowing it's prime means I can just say to myself, I know it's prime, and not worry about it. And then I'm done. And I can verify that my answer is right by multiplying it together. And I really do recommend that you do multiply these together, particularly at the end of your test, to make sure that, that you got it going on. And so I would recommend that, definitely. Okay, so I think that's it on that problem. I'm not going to multiply it together because I'm really tired, but you guys can multiply it together if you like. Start here, those two things, and then multiply through by 10 to verify. Okay, so here we are, and I can see, oh, it's a binomial. So I say to myself, since it's a binomial, does it have a greatest common factor other than 1? Well, it has 1 in common because there's a 1 right there, right? 1. Then I say to myself, is it a difference of squares? And remember what we said about the difference of squares? We said x to the second, x to the fourth, or x to the sixth, or x to the eighth. Had to be multiples of 2, right? And you notice we have x to the sixth. So this term right here, you might not be saying, hey, that's a perfect square. But it is. It's a perfect square. It's in the list. And 8's a perfect square. That's 8 squared. 64 is a perfect square. That's 8 squared. I was looking at hummingbirds and saying that, talking about that. And then this guy is any variable, right, raised to the 6 is a perfect square. So, yep, it is. And you have to factor, there is a strategy for factoring, and you have to factor it in that order. And sometimes it doesn't make any difference. You can still get to the same order, the same answer, even if you did it out of order. But this is not a time when that applies. So you have to do the difference of squares, otherwise you will not, so somebody might say, hey, isn't this a cube? And yes, you are right, it is a cube, but order matters, and the factoring order, you have to do the difference of squares before you do the cube. So this is what cube, what squared, because remember I said difference of squares. So I'm going to fill in those spots. So this is x to the third. And this pen's bad, terrible, terrible. Not very, I should make more room when I write it. 4 to the, no, it's 8 because it's square. So 8 squared and y to the third. And so make sure that this is that power rule, right? 8 to the second is 64. Y to the third to the second. I know this pencil, that pen is just terrible. And so I have it, right? Now, the formula for difference of squares is not finger over threes, write what you see. That's not the formula for the difference of squares. So I'm factoring the difference of squares. So if I start using the cube formula, that won't work. The difference of squares formula is this. Add bases. It's easier. Subtract bases. And you don't have to write the formula out. ES, I forgot one of the S's, and I had, I don't know what I had. I think I had a bass in a lake is what I think I maybe had. So you add the bases and you subtract the bases. Now the bases are the part underneath the exponent 2 because it was a difference of squares. Squares is the 2. So the base is the part underneath the exponent 2, which is x to the third. Add the bases, right? And underneath the exponent 2, 8y to the third. And then subtract the bases, x to the third minus 8y to the third. Now, if you FOIL this together, you'll get what you started with, right? X to the third times x to the third, add the exponents is x to the sixth, or use your fingers. X, that's what x to the third is. X, that's what x to the third is. So when I take x to the third and I multiply it by x to the third and I count all those x's, there's 6 of them, x to the sixth, right? Which is, boink, what I wanted. And then this is a negative 8x to the third, y to the third, and then a positive 8x to the third, y to the third. Remember, write them in alphabetical order, and they're 0. They get rid of each other. And then a positive times a negative is a negative, and 8 times 8 is 64, y to the sixth, right? Y to the third times y to the third is y to the sixth. Use your fingers again, if you like. So you can see, oh yeah, that is what I started with. And you always have to make sure that you're not all done, right? And so, and before we were checking to see if we were all done, and we were saying, oh, we are all done. So is there a greatest common factor here other than 1? And I'm not expecting it to be true, that there would be 1. And there isn't. It's just 1. And then, is it a difference of squares? Well, the exponents would be 2, 4, or 6, right? But the exponent's 3. So really on a binomial, there's a third guy, and it's the cube. And you notice that this is a cube. You guys notice that? And this guy is another cube. So like they made this like fancy thing. And so now I'm going to have to really get to factoring here, but don't worry, it's not going to be that bad. And so because this is a cube, I want to factor it. So what to the third plus what to the third? Well, this is x. This is 2, because 2 to the third is 8, and y. And so I'm finger over threes. I'm whipping out the cube formula, right? Because it's a cube. Write what you see, and I know that it's going to be a binomial times a trinomial. And I'm doing these one at a time. This one is this. And then I'll do the other one, and I'll put it here, right? So this is finger over 3's, write what you see, x plus 2y. Square it, x squared. Multiply them together, 2xy. Square it. Now, when it's got two pieces, you got to square both pieces. 2 squared is 4, y squared. Signs. Soap, same as I started with, minus, right, because this is positive, always positive. And then the next piece, and I think I have another pencil color. You know, I had another pencil color. I don't know. I lose my stuff. I'm really terrible. I have all this stuff everywhere. My office, my bedroom, everything all in one, right? Everybody's got that going on, so I'm going to put that here. And so when I factor that, right, it's a cube. So I'm thinking what cubed minus what cubed, and it happens to be the same, x and 2y, just because of how it was built, right? And so finger over 3's, write what you see. And probably most of you are saying, hey, this is going to be exactly the same except for the signs are going to be different. And you're right. You're very right about that. It's going to be exactly the same except for the signs are going to be different. So I think I'll sing my song in my head here. 2xy multiply, square, so 4y squared. Soap, same as I started with, and opposite, and always positive. So this is my answer for the whole thing. It was built of 2 pieces, but it's my answer for the whole thing. This won't factor any further because it's a binomial. It doesn't have a greatest common factor. It's not a difference of squares. It's not a cube. I use the cube formula to get this trinomial, so it's prime. Same, doesn't have a greatest common factor, not a difference of squares, not a cube, so it won't factor any further. And that one I use the cube formula to get it, so the trinomial in the cube formula is prime. The back of the book might leave it there, or they might say, you know, binomials to the front and trinomials to the back, and then rewrite it. I actually have looked, and a lot of books do rewrite it with binomials in the front and trinomials in the back, and your book did not. They just left it like that. So you might see, if you go and watch somebody do this, you might see someone reorder it like this, because the binomials first, and then the trinomials. And I'm okay. I don't care if you do this or not. It's great if you do it. Or it's great if you don't. So that's great. So that was like the grand finale on the factoring there. And so we did a lovely job on that. And we'll say goodbye.